Alright, I have my geometry displayed for my CAD file of this part, and I've also have the MBD data, or the GD&T, built right into the model for me. So I can tell what areas are critical and what are not, so it allows me to control what I'm inspecting to, what is important, and not waste my time inspecting the whole thing when I only need to pay attention to a small part of it. So I can actually turn that off, and now I need to align the CAD data to what I physically have for a part. In doing so, all you have to do is create targets. And I'm going to use the target hotkey. So create target 1. I'm going to align to the top of the part. So I'll do target 1, 2, 3, and 4. That way I can get this top plane aligned. I'll do 2 on the front flats to get that side. And I'm going to do 1 on the right side, so I have the top, front, and right side. About 7 targets. Usually you want at least about 5 or more to be fairly accurate for measuring, especially on more complicated parts with more walls and features inside of them. The more targets you have, the better. But they do take time, as you have to align to all of them. So it's a fine balance between accuracy and speed. Now, once I have all my targets created, I can go up and say run auto align. What this allows me to do is I can take the 3D gauge arm, and I'll go down and touch off on the points it calls out. So I'm going to touch off on point 1, 2, 3, 4, and now you can see my probe is actually displayed on the screen as it gets slowly more and more accurate representation of the part. I'll do the front, and I'll do the point on the right side. Now, once I've done the auto align, it puts me into inspection or build mode. What this allows me to do is actually, on a live view, go through and put my probe right on the part, and it gives me a report to that surface of what its tolerance is to the CAD model. So I can tell this flat surface, it's about 1 thou or so above what it should be, but that's well within tolerance. Or if I could do the bottom of the pocket here, or the walls of it, I could do the floor of the holes, but this does not show me diameters. So what I can do is I'm going to put up the 3D gauge arm, I'll close out of inspection mode, and then I'll hide my target so I don't have to see them. So the auto line remains. What I can do is then I can go up and I can go to the Verisurf menu, and I'm going to go measure, and through the measure menu I can choose not just individual points or to a surface, but I can measure different features such as points for points in space, usually like the center point of holes, measuring lines, circles, ellipses, slots, splines, and planes. Very powerful tools throughout this. So I'm going to start off with getting these center points of these 4 holes on top of my part. I can go measure a point, and because my probe is slightly bigger than the hole's diameter, I'm not going to be truly accurate in Z, but my X and Y will be very accurate. So I can actually just put it right in the hole and it will center itself. Hole 1, 2, 3, 4. I can close out of this. I've measured my 4 holes. Now I'm going to do these blind holes down here in this larger diameter. So I'm going to use my circle tool. Now in this I have options for probe compensation. Usually the automatically compensation works a lot of the time, but you also have option to force it to use the inner diameter, no compensation, or the outer diameter. So it depends what side of the circle you're measuring. I'll leave it at auto, and this is determined by the direction the arm faces when it's measured. And it's very decent at figuring out where it is in space. And so for holes it takes 4 points. And you can vary this whether it's 3 or takes 6 points or as many as you want. So I'm going to grab 1, 2, 3, 4. That lets me know it's a complete hole measured. Now I'll get this little boss in the center. So that's 1, 2, 3, 4. Now I can do this for all these little holes in here. So it's just 1, 2, 3, 4, and just keep going around. very quickly, I can find all the diameters, all the center points of those holes. I'll say finish. And now what I can do with this information is I can generate a report. So I can go to, I'll right click on my features and I can say report. I'll have it generate a report based off all this information, and it's going to go through and process it and output either a PDF, HTML file, Excel file, whatever you want, and will generate a report, give me nominal information about positional tolerance, diameter tolerance, roundness, depends on what you're doing. For line, usually it's angle and length and straightness. Holes have a positional tolerance, roundness tolerance. It's anything that could be pertain to that individual feature can be reported and even shown graphically on the right, as well as giving the positive tolerance, the negative tolerance for what you define as tolerance, and the deviation to what is measured versus the nominal value. Some of the other measuring tools inside of Verisurf include for measuring for slots and also 3D geometry, such as spheres and cones. So all it is measure, and I'm going to say I want to measure a slot. And that requires 6 points. Once again, you can adjust this just like you can with a circle. So I can go in and pick 1, 2, 3, 4, 5, 6. And it finds my slot for me. And then I can generate a report on it. Now, spheres and cones are a little more tricky. So I'm going to go to Verisurf, my measure tool, and I'll say cone. This requires 8 points, 4 at the bottom, 4 at the top. 1, 2, 3, 4. 1, 2, 3, 4. And my cone has been built. This is more for checking your angled walls. I'll finish. So my cone is generated. Now I have to do a half circle here, which is kind of a hard thing, unless I do a sphere, and then I can measure the diameter of that and check the surface to it. So I'll go measure a sphere. Now I can do 9 points in this and be fairly accurate, or I can use the continuous points mode. So rather than picking one individual point so many times, I can gather a small cloud of points and do a high number of them just by holding down on the mouse button. So I'll go in and hold down, and every angle change will gather a point. And like that, I've gathered 100 points in just a few seconds and built the sphere from it. Alright, not only can the 3D Gage arm in combination with Verisurf pick up flat features, but it also can compare complex surfaces. So I have my 3D model, I have my part. So first thing I'm going to do is I'm going to go through and I will create targets. And I'll target for the top plane, the front plane, and the right side plane. That way I auto-align everything, in which case I'll go run auto-align. I'm going to measure point 1, so I'm going to grab my top plane, and these points, you measure them in the order they are created. 1, 2, 3, 4, 'Alright, now that I am in inspection build mode, I can actually do a combination of continuous points and inspection mode to lay down points along the surface to compare this complex model. So I'll switch to continuous points mode. Then I can just hold down the button on the 3D Gage arm and it will do a broad spectrum compare. And very rapidly gather point data for me. In turn, I can use this to quickly make an image that shows the in tolerance areas, the out of tolerance areas, Like that, I've gathered almost 300 points of data to use. Then I can say finish. And from that, I can have an analysis made where I can say, show me a surface mesh of it and a color map that can define where I'm in target for my tolerance and where I'm out of target for my tolerance. So for here, I can go in, I can say that I want 3D spheres shown that are the probe radius. So I can go through and I can see very quickly, okay, the whole top is in tolerance. I am a little loose down on this corner, but other than that, everything looks right. And you can do this for any surface, even flat ones as well, for measuring if they have curves in them. It's a very useful application of the 3D Gage arm, and you can measure multiple surfaces at a time and create a whole heat map for your part on where areas meet your specifications and when they don't. Okay, I've gone through and I've scanned the top, the right side, front side, left side, and back side, and built an analysis so you can see top's alright, though the sides are a little out of tolerance. Normally that'd be a fail for the part, but I can actually go in and see if a best fit will solve some of this and give me better tolerance on all my parts. So all I have to do is select my points, go up to the best fit tool. I'll set my parameters, so how many iterations, the rejection distance. I'll tell it make a best fit. It's going to go through all of my points, and it's going to have an average deviation of -9/10. And then once I do that, I'm going to analyze again. And from that analyze, you can see all of a sudden all the analyze functions I did before, they're now green now. So I'll say OK, and I'll apply all the points and features, yes. So I'll just go through and I'm going to turn off. You see, it was an issue of tolerance, but with alignment. And now everything has become much more accurate and true. It's just been realigned so that all points will fit for it.